In this video, we're going to talk about sigma notation. Now, what's sigma notation? I'm sure you've seen this sign before. This is sigma. In mathematics, this means the sum. And you will see sometimes you have a letter here, which is called an index. So they can say, for example, I equals, let's say, 4 all the way to, for example, 9. And here, after sigma, you have another expression, and that expression can be, let's say, I squared. Now we need to understand what it means. This I that you see here on the bottom, it's called, this I here is called the index of summation. And I like to call it the counter. So I like to call it also the counter, because basically what we're doing here, we're counting. We are counting from 4 to 9. So this is where we start here at 4, and this number here indicates where we stop. So what does that mean? Sigma here means summation, like I said, so we're gonna add stuff. We start when I equals 4, that's where we start. I equals 4. What do we do with this 4? We look at the expression that's here inside the sigma notation, and we plug 4 wherever we see I. So if we do that, we're going to have 4 squared. So we get 4 squared. We do the same thing when I equals 5, because the increment here is 1. So we count from 4 to 9. So it would be 4, 5, 6, 7, 8, and 9. When I equals 5, we plug the 5 inside this expression here, and we get 5 squared. Remember, I is 5, so when you plug 5 into I, you get 5 squared. And then, and so on and so forth. So when I equals 6, you get 6 squared, and you keep going. I equals 7, you get 7 squared. I equals 8, you get 8 squared. I equals 9, remember that's the end point. It's 9 squared. But what do you do with all these numbers? Remember, it's the summation, so you add all of them, and that's what the sigma, this expression here to the left, stands for. So for each value of I, you plug that into the expression that's inside the sigma, and you get a number, and you add all of those numbers from the starting point here, which is 4, to the end point over here, which is 9. So, and if you want an exact answer for this, you just have to compute them. 4 squared plus 5 squared, and so on and so forth. Now, let's go over some properties of sigma here. The first thing that we should know is that sigma is linear. And I'm going to explain that using an example. Before we use an example, there are some formulas that I want us to remember. So important formulas. Those are the sigma, the summation formulas. The first one is, if you have this summation here, I equals 1 to n. N is a number. N can be 2, can be 20, can be 1000, anything. So you start from I and you end at n, and the summation of the I, the answer is n times n plus 1 divided by 2. And the second formula is I equals 1, summation from I equals 1 to n of I squared. So this is equal to n times n plus 1 times 2n plus 1 divided by 6. So in the problems, what we will have to do is to be able to use these formulas. What I want you to notice is that on the right hand side of these formulas here, you don't see I anymore. You don't see that counter anymore. So it's only expressed in terms of n, the end point. Okay, so that's one thing that you have to remember here. Let's go over an example to make sure that we can use it. Let's say we want to compute, so compute sigma summation from I equals 1 to 12 of I. Oh, when you look at this expression now, when you look at this expression, it looks more like this one on top with n being 12. So we're going to use exactly that formula. So this would be equal to, so I'm just going to write beneath it, this would be equal to n times n plus 1 divided by 2. But I know what n is. What's n? N is 12. So it's going to be equal to 12 plus 1 divided by 2. Remember, n here is 12. And then, so you get 12 times 13 divided by 2. So if you compute that, you should get 78. So this is the answer. So the summation from I equals 1 to 12 of I is equal to 78. So what does that mean? It means that on the left hand side here, it means we have 1 plus 2 plus 3 plus, we keep going up to, remember the end point here is 12, up to 12, this is 78. And you can verify that also by hand. Now, we're going to use the linearity of sigma, as I told you earlier. Let's say we want to compute the summation I equals 1 to 20 of 2i minus 8. Sigma here is linear, like I told you. So it means that we can distribute this sigma to this expression and that expression to 2i and 8. So sort of. So what does that mean? It means this is equal to sigma I equals 1 to 20 of 2i minus sigma I equals 1 to 20 of 8. So that's the property of sigma. You can distribute, if you have a plus sign or a minus sign, you can distribute the sigma throughout the terms. Now, the second property of the linearity of sigma is that if you have an expression that multiplies I, the counter, in this case, so for example, here we have 2 times I. So you can bring that 2 to the front. You can bring that 2 to the front. So when we do that, we get 2 times sigma I equals 1 to 20 I minus here we have I equals 1 to 20 times 8. Oh, at this point, we remember the formulas. Look at this expression here. We can use the first formula of sigma notation. So this would be equal to 2, and then whatever is in yellow would be, because n now is 20, it would be 20 times 20 plus 1 divided by 2. So that's what we have in yellow brackets. Minus, okay, now this is also sort of a formula. So here we don't have any counter, we don't have any I in there. We just have a constant 8, and we count from 1 to 20. So when you have that constant, you just have to multiply that constant by n. So this is equal to 8 times n, and here is 20. So minus 8 times 20. So that's what you have. And then if you compute this, you get 260. So that's the answer. Now, my exercise for you is the following. So you have problem, compute I equals 1 to 33, 7I plus 15. So in this case, your answer should be a number, exactly the way we did before. So make sure you use the linearity of the sigma notation.